Give me a moment, please. All right, guys. So today is November 21st, Sunday in India, and Saturday night here in California, for those of you who are uh, joining from California. The goal today is to do a lab on a practical data set, an old data set rather, but it's quite practical for regression in a meaningful way. Now, before we do that, this is a small recap of what we learned in regression. Regression is the process of predicting a number, a real number, a scalar or a measurable quantity in response to some inputs. You build a model into which you feed in some features of the input data, and then what you get is a response. The response is a number. Now, in simple terms, I said it's a number. Actually, I'm oversimplifying a bit. It could be not just a number, it could actually be a vector in itself. But we won't go there for the purposes of getting started with machine learning. Just assume that it is a number. Now, given that we have that, we use all sorts of words, features, inputs, predictors. These are all synonyms as far as we are concerned, or independent variables or regressors for input. And for output, we use target variable, output response, and dependent variable. You'll see that for inputs, I interchangeably use features or input or predictors based on the context to elucidate the meaning. And then on the response side, I'll use the word target variable, output response. But these are numbers. It's a part of supervised learning. Why? Because you have to train with data, label data, and then thereafter you use it to make inference or prediction, the two halves. Remember, training is one part of it, and then inference is the other. Part of training is to make the machine learn from the data, then to cross-validate, and then to test it out, see if the model works well on unforeseen data. And then finally, if you're convinced your model is good, then you deploy it to production. So with that being there, we did the simple situation of univariate regression in which you have a target variable based on one. Now remember that when you build a model, your model will make mistakes. It will make prediction. There will be a gap between prediction and reality with respect to the training data. That gap is the residual error. Now, the sum of square, now the total error of the model for the training data, or for the test data for that matter, but for training data while you're training it, you can have a different loss. People often use the word loss function. I will just use the word measure of error. You can measure error by just adding up and taking the mean of the absolute values. You take absolute values, otherwise the positive and the negatives will cancel each other out. But mean absolute error is not used as often as the mean squared error. If you square the error terms from each of the prediction and you add them up, and then of course you divide it by the total, you'll get the mean squared error. Now, mean squared error is much more used for a reason, actually. Under certain conditions, which are called um, Gauss-Markov assumptions, if those certain assumptions are true, and we won't go too much into that, but basically, if the data is what you think it is mutually independent, instances of data are mutually independent, and so on and so forth. So then there is a theorem that is attributed to Gauss-Markov theorem. It is also called BLUE in economics, those of you who do econometrics, the best linear uh, unbiased estimator. So what it means is it's a long term. What it basically says is that use the sum squared error, mean squared error, preferentially. In most situations, it is a better function to take and to minimize as a loss function than mean absolute error. Right? You tend to use mean absolute error only when you don't want to be too sensitive to outliers. And there are situations like that. So we'll talk about that. We also talked about gradient descent. Gradient descent is the step. You take a step against the gradient, against the slope. In one dimension, it's slope. In higher dimensions, it is more than slope. It is the gradient generalization of that. You go against the gradient. So we won't recapitulate a lot of that. But just a few pictures here to illustrate what I'm saying. If you remember, in linear regression, in simple linear regression, the loss surface is sort of a paraboloid. It's a convex surface with a single minima. That minima gives you the optimal value of the parameters in the parameter space or the hypothesis space. So you achieve that by a process of gradient descent. You go against the gradient and you reach that. We talked about a concept called the bias variance trade-off. Right? Now, bias and variance, when you build models, you can build models of different degrees of complexity. You can make very simple models, you can make very complicated models, and different kinds of models will produce different amounts of errors. Now, the sum total error that a model has with respect to the reality in the training data, it is broken up into three parts. The error that comes from bias, these are called bias errors, the errors that come from variance, and the irreducible error. So just to recap, irreducible error is something you technically can't do much about. It is the partly instrumentation error, partly it captures that which your model doesn't know. One example I gave you for entrepreneurs on the beach was if you're just looking at temperature to determine how much ice cream you'll sell on the beach, you would realize that it is insufficient information. For example, day of the week matters, holiday or not holiday matters. Uh, Beaches are filled with children and parents bringing them to the beach. So work days, you don't see as much activity as you see on holidays and weekends. So if you don't include that factor, then you are introducing a significant amount of irreducible error, an error that your model simply cannot uh, get rid of because you it there's a spread caused by a factor that you haven't considered. Right? So for the same temperature on the workday, you would sell far less ice cream than on the weekend. So with that being there, bias and variance errors are the ones that you can reduce. Now, I told you about how to look at it. If you look at the situation A here, A is your perfect. If you think of it as a dartboard, which is a fairly good analogy for this, if you throw darts at a dartboard and you hit close to the bullseye, then you have a model which is very good. Look at B. In B, all those darts have landed up pretty close to each other. They're close, but they're off the target. It's almost as though the machine that you're using to throw the darts has a slight bias. When it aims for the center, it actually the instrument is pointed to northeast of the center, isn't it? And so that is the B situation. You have a bias. The machine has a certain instrumentation bias in some sense. And so your model has a certain instrumentation bias. It always tends to predict a little off center of what it should. Now, the variance error is what you see in situation C. Here, what happens? The darts are all over the place. Okay? Maybe the average of their location may be the bullseye, but you see it all over the place. Um, there's a huge variance of where the dart will land, isn't it? So that is your variance error. Now, bias errors come because your model may be too simple, right? Quite often uh, is simpler than the underlying reality. So we took this example in which one, suppose your data are those, if you look at that curve out here, I'm looking at this situation here, then all those white points on the left that you see are the points. Now, model one is too simple. Model 2 is also too simple. Model 3 is perfect. It seems to go through the data. And model 4 is overfitting the data. When you overfit, you have variance errors. When you underfit, you tend to have bias errors. That's one way to think about it. Okay. And this is a recap of what we did. So, and therefore, this famous oft-quoted diagram that as you make your model more and more complex, do you notice that your yellow line is coming down, right? So let me, in case your screen is not showing it in big, yes. So I hope now this picture is pretty big and clear. Look at these lines. The yellow line here represents the curve represents the fact that as you make your models more complex, your bias errors goes down. On the other hand, the red line reflects the fact that well, I'm calling it a line, but actually it's a curve. The red curve represents the fact that as you make your models more complex, then your variance errors goes down. But leaving aside the irreducible error, the reducible error part is the total of your bias and variance error. So that is the green line. And if you notice that that green line achieves its minima at a place at which you have certain degree of bias errors and a certain degree of variance errors, but it's a good trade-off. And usually when you have a minima of your reducible errors, quite likely it is that is the best model, or the complexity of the model is sort of resonates or is very matched by the complexity of the underlying data itself. You know, the forces that truly produce the data. So behind data, there are certain forces at work. And the equations for that, the unknown equations or the dynamics, has a certain degree of complexity. When you build a model whose complexity sort of matches that, you tend to have a good point at which your bias variance trade-off or the sum total reducible error achieves some minima. Are we together, guys? So this is a recap of what we did. Now, again, we talked about many things. Hang on. One, we talked about the Occam's razor principle, which basically says that in science, the simplest effective explanation is the right one. So our job is to find the simplest explanation that works. So I won't review classification because today's lab that we'll do is about regression. We need to do a few labs now, and I will take this as an example. So, excuse me, guys. So let me know when it is clear and legible on your screen. Are you guys able to see it? Are you able to see some code on my screen?
Yes, sir.
Yeah, yes, yes.
So ignore the first part. It is just HTML formatting. I like to format my content, my notebooks carefully. So let me give you a little bit of an idea about the California housing dataset. California in US, the US has extreme weather. Guys, if you could please mute yourself. Yeah. Either you're speaking and I'm not able to hear you, or You don't know that you're on mute. Okay, now everybody is on mute. Okay. So California is a state in the United States, US, right? And it is on the west coast of US. It's next to the Pacific, the beautiful Pacific Ocean. Now, there are many states, about 50 states in the US, and then there are certain territories, US territories. But California is often considered sort of a jewel of a state because the weather here is just excellent. If you go to much of US, you get fairly extreme weathers. Like, for example, I lived close to New York for many years, and then Chicago. New York areas, they're beautiful upstate New York. Beautiful fall season. If you want to know what I mean by the word fall season, just Google up for pictures of the fall season. You'll see. So it is very beautiful during fall season, lovely spring and summer. Summers are quite hot, actually quite not hot like India, but still warm. Winters are very arctic. They're very cold. You get a lot of snowfall. If you think Shimla is cold, you have think many times colder than that. It's very, very cold. Temperature goes down to minus 50 degrees centigrade sometimes. So you can imagine how cold it is. Literally, people's car engines, they crack under the cold. So that level of cold. Then there are places which are like Chicago, etc. Very, very windy. There are parts of America where tornadoes come, and those tornadoes are just huge. Nothing like people outside US have not seen tornadoes like that. In India, certainly we don't get tornadoes like that. They come and they blow your house away. Right? They create a lot of devastation. Then south of the southern parts, they get these hurricanes, monstrous hurricanes that pour a lot of water onto the land. And the south can also be hot, very, very hot, even hotter than India. So the hottest then, so from all of these things, you get pretty awful weather in much of US. Um, it's almost crazy that so many people live here and that this is the most advanced country in the world. But then there are parts of America which are very mild weather. The West Coast um, has pretty mild weather because the just like the Himalayas protect India from the cold of the uh, northern regions, in the same way, you don't get the windswept feeling that you get in Mongolia. The Himalayas protect you from that. India stays pretty warm and mild. In the same way, there are the Rocky Mountains that keep California pretty mild. Much of the bad weather stays on the rest of US. On the west coast, you have California, Oregon, Washington. Pretty good weather. Now, Oregon has a lot of rain. Almost every day it seems to rain there. Then Washington, Seattle has a similar situation and it gets cold. But California is sort of a jewel in the sense that like especially where we live, Silicon Valley, there's a reason why Silicon Valley is the mecca of technology. Weather here is always mild. You can roam around in shorts and t-shirt, or maybe you'll have to put on a full shirt and a tracksuit or something like that. Winters, the coldest it gets is um, still so pleasant that it is the envy of the rest of the country. Summers, it never gets hot. So it sort of stays naturally air conditioned in many ways. So you can imagine that California, with all it, and it is extremely beautiful. You have the beautiful redwood forests, you have the sea, you have the ocean, of course, the Pacific Ocean. You have the beautiful Rocky Mountains. So, for example, if you're in Silicon Valley, the Pacific Ocean is, let's say, 20 minutes away, or half an hour or 1 hour away, depending upon where you live. And on the other hand, the beautiful Sierra Mountains and the snow-capped mountains and those redwood trees, they are another couple of hours away in the other direction. So imagine that you live between the sea and the ocean, the sea and the mountains, beautiful mountains, and in between is the valley. Right? So you can imagine how beautiful it is. It's also the place that a lot of people in the world want to come and settle down in for obvious reasons. It's California is arguably the most prosperous state in the country. If it were a country, it would still be, I think, the fifth biggest economy or sixth biggest economy in the world, which is that big and prosperous. So everybody wants to move to California. Who wouldn't want to move here? Prosperous, wonderful weather, right? The ocean, excellent, lovely nature. Mount, you can do mountaineering one day, you can do skiing the next day, you can the third day you can go and do windsurfing in the ocean. So it's like that. So the house prices here are exorbitant. In fact, some of the most expensive places in the world are in California, the real estate. The San Francisco Bay Area, where we live, the real estate is ridiculously expensive in this area. So one of the things that people want to do, or this particular data set looks at, it's an old data set, I believe it's 1995. So house prices in 25 years have more than tripled. So whatever numbers you see here, the reality today is almost three times. 1995 is before the dot-com revolution, before, I mean, literally when the internet was beginning to happen. Today, of course, Silicon Valley is a different thing. So whatever prices you'll see in this data set, we have three, four times. But nonetheless, it gives you a pretty good idea about California. This data set is often used as a part of your necessary training in machine learning. And so we will use that. We'll study this data set. I'll go over this carefully. So exploring the data, so could you guys guess, what are we doing in this paragraphs here that you're seeing on the screen? Import NumPy as NP, Pandas as PD. What do you think this is, guys? What are we doing here? Could somebody speak up?
We are just importing the libraries here.
Exactly. We
Okay.
So NumPy and Pandas we have seen from the previous lab, but let me talk about Pandas profiling. Pandas profiling is a tool that gives you automatic uh, exploratory data analysis. In other words, it helps you explore the data in a systematic way. And a lot of the boilerplate or routine things it does for you quickly. Now, Scikit-learn is a machine learning library. We are going to include and by the way, this lab is heavy. Yeah? So if some parts of it you don't understand, that's perfectly okay. Uh, you split the data between test and train. Why? Because you want to train on some part of the data, hide some part under your pillow. We did that in your lab one. Similar concept. There is something called the standard scalar. What the standard scalar does is it standardizes the data. What happens is that, suppose, imagine that you're looking at an elephant. Now, if you measure the weight of the elephant, it will be in thousands of pounds, thousands of kg, like, I don't know, thousands of kgs or so forth, thousands of kgs actually. If on the other hand, you're measuring the size of its tooth, not the big tusk, but the tooth or something, some small thing, the numbers would be very small. So if one predictor is the size of the tooth or the number of teeth it has, no, or the other predictor is the weight of the elephant, you would imagine that these two features, they will look rather odd once the value of one will be in centimeters or millimeters, the value of the other will be in thousands of kgs. Right? So one of the things you do is that because the units differ so much for different data, and by the way, who says that the for example the teeth, the size of the tooth can need be small. If you insist on measuring it in micrometers, then even the size of the tooth will look enormous. Right? So because of the scale or the units that people use for measuring things can widely differ, one easy way is to make it scale invariant or dimensionless quantity. Right? And when you make it dimensionless, uh, you normalize it in some sense. There are many ways of doing it. One standard way is the so-called standard scalar. We'll talk more about it, but for now, just assume that it's a way that will put all values between approximately -3 and +3, right? Irrespective of what the original set was. Polynomial features is to do exactly that, to do take features and take polynomial or higher order terms of the feature. Pipeline is a command. It's a very useful thing. It helps you make a pipeline of things to do. So for example, you want to do scale the data, then you want to feed it, make polynomial features, and then you want to do regression. So it will help you do all of them. Now, the classifiers you can ignore because we are not doing the classifiers. This is unnecessary for this file. And then for regression, we're going to do some regression things. Now, Matplotlib is our plotting libraries, if you remember, we are going to use it. One new library that I'm using here is Folium. Folium is a lovely library that helps you make maps. Very easily, it will help us make maps. All right.
So here, sir, in the figure size, it is we have to take as 20 and 10 itself. It is a fixed one, or it can be varied, sir.
Oh, it is. So these are aesthetics. No? What happens is that it is your choice, whatever looks good for you on your screen. So what I'm saying is width is 20 and height is 10. This is in terms of units. Now, those units are matplotlib units. Generally, you play with these. If you don't, right, you'll end up with a square picture or something like that. 10 by 10 would be a square, right? But because most of our computer screens, you notice that they are twice as wide as they are high. Therefore, pictures look better if you use a 2:1 ratio. It is just
So,
a
but where we get all the standards, sir? Like for example, the Ligand dot font size is equals to 16. So where do we get all this standard size, sir? Like it is inbuilt, or
no,
it is
no.
just an assumption what we are making?
No, it is your own. See, okay, so that is a good question. Actually, all of these RC params that you see, you can ignore all of them. If you don't do it, your notebook will look just as good. So, but why do we do that? Or why do I do that? See, what happens is when you create your Jupyter notebooks in the beginning, it will look very basic. Huh? You try, you do a lot of work. You may get a perfectly good analysis, but how should I put it? You may have a perfectly good car with an excellent engine. But at the end of the day, you want it to look pretty also, right? You want to paint the car, isn't it? Give it a nice polish and so on and so forth. In the same way, when you write your scientific or your data science notebooks, and in that notebook, you draw some pictures. Once you have done your whole analysis, you go back and you prettify your picture. You add aesthetics to it. And when you start adding aesthetics, you start playing with the font size, the font family, the size of the picture, how much horizontal, how much vertical. And those are things, there's nothing great about them in the sense that, it's something you do. If you do HTML also, you prettify a web page. So those are all the aesthetic elements. It comes by playing with it. Yeah. If you don't use it by default, I think the font size differs from machine to machine, what the default is. Right? Some machine will have this, somebody else's laptop will have that. But by explicitly stating, you hope that on most people's laptops, your notebook looks the way you want it to look. Right? So you control the aesthetics. That's what we are doing. Does that answer your question?
Yes, sir. Thank you.
Yeah. That's all it is. Huh? So whenever you see those things, you can sort of ignore it. Also, do you see this thing called used LaTeX, used text? In your case, always keep it false. Huh? In my case, I use it because actually this notebook is part of a book I'm writing. And so it's a famous data set. A lot of people analyze this, but it is actually part of a book. So you will notice that as we go through this, you'll notice that I've given some consideration to the aesthetics because when you write a textbook, it is important that the graphics look clean and nice. Right? By the way, for that same reason, I'll request you. I'll of course post this notebook onto the course website, but please do not share it. Do not circulate it around because there may be copyrights problem. If, for example, somebody posts it in their own name on the internet, copies it and posts it in their own name on the internet, I will have problem because my publisher will then complain or may reject my chapter or this particular part, saying that it is a copy of somebody else's work, whereas of course it's original work. But the copyright laws are strange actually. When publishers are very, very worried. And so if what you're seeing is pre-production or pre-publication notebook, but it is, I think, useful. I thought I'll create a more basic version of it, but I thought, why not show you guys how to do it? Not only do it, but to do it with aesthetics, with some, polish to it. But for that same reason, please do respect that. Don't share it. At least till my book comes out, don't share it. After my book comes out, of course, feel free to share it. Okay? So there's nothing extraordinary original about this, but I have paid a little bit of attention to the aesthetics. So this is it. This is your data frame. But if you notice that I have prettified the data frame. By the way, a lot of these aesthetic elements you can just sort of ignore. Right? But if you look at this data, it has a few fields. For every house, so the way this data is organized is it is looking at the house prices, median house price in a street, they call it a block. The word block is unknown in India. What we call it as a street or a set of houses on a road, right, is a block. So the predictors are longitude, latitude, which give you what? The location of the house, the geographical location. Now, when you're trying to buy a house or sell a house, the value of the house, also you would agree, does depend upon the age of the house, isn't it, guys? It will depend on the age of the house also. Uh, excuse me, guys, for 1 second. Yes, it will also depend on the number of rooms. When you buy homes in Bangalore or wherever you are, you want more rooms, isn't it? Like if I tell you that there is a house with just one room, you essentially assume that it's a low-income housing, isn't it? You don't expect it to be a mansion, the whole mansion being one room. So the number of rooms matter. Total number of bedrooms matter because how many bedrooms there are. The population matters. Why? Why does population matter? You may have a big house in a rural area. It won't be as expensive as a big house or even a small house in a high population area. High population areas are cities, right? In cities, houses are more expensive. As you know, Bangalore real estate is very, very expensive. Most people, they live in relatively small houses compared to more rural areas or B cities and so forth, where you can get a much bigger house. So that's the population factor. Households is how many households are living in that house. Is it in a given street? How many, like, it's sort of a very American thing, total number of households, because in US you have an emphasis on single families, nuclear families, single family homes, etc. In the Indian context, it gets a little bit blurry, but so ignore it. Median income. Median income is basically a median amount of income that people make who live there. And then one more predictor is the ocean proximity, which is a very California thing. Much of California has a coastline. It's a very long state and you'll see it in the map. And most of us live between the ocean and the hills, right, in the mountains. So proximity to the ocean matters because everybody wants to go to the beach, um, sit there with the family, enjoy with the family, surf the waves, and go boating and do all sorts of water activities. It's a pretty much a California character to do all of these things. Now, what is the target variable? What is our output that we want to predict? build a model to predict. It's the median house value. So if you know the location, if you know the people, the age of the house, the older homes, of course, may either be more expensive or less expensive. Actually, paradoxically, in India, older homes they depreciate, right? But in US, the older a home gets, the generally it doesn't depreciate. It in fact becomes more and more expensive because those neighborhoods become very well settled and with very clear, stable demographics. So older homes paradoxically are more expensive. So anyway, we'll look at the data. Now, when I look at this data.trans describe, what am I saying? I'm just saying the same thing. See, if you just gave this line of code, it will just show you the data and the basic statistics. But the same thing, if I wrap it up with a bit of aesthetics, all of this aesthetics, then you get this nice HTML table. So guys, I've been talking for an hour. Let's take a quick break for 5 minutes. I need to take a call and I will take it up after that. I'll stop the recording. So sorry, pause it. It is 10:23 in my clock, so it means it's noon, almost noon in your clock in India. Let us take a 10 minutes break. Huh? All right, guys. I'll see you guys in 10 minutes. All right, guys, 2-3 minutes more and we'll get started.
Sir, I have a doubt on the previous homework.
Go ahead. You've gone mute. Can you guys hear me?
Yes, we
Yes,
can.
sir. Yes, sir.
Yeah, yes. So the person, the gentleman who was asking this question has gone mute again.
Yeah, actually, the plot for the SVM that I got from the homework, one of that, when I plotted for the residual plot, I get a distribution with two peaks. So how do we interpret that?
Let's
The
take it in the project, the session that I wanted to give for
okay,
lab help. Show it to you.
okay,
But generally, you have to look at the size of the residuals. If there are, see, the peaks may be there, but if the peaks are very small, then it doesn't matter. If the peaks are substantial, then there's something wrong. Then we should look at it.
okay, sir.
It's hard to tell without seeing the notebook.
Okay, we'll share it later.
Sure. All right, guys. So we'll get started. Let's get started. Huh? I'll resume the recording just for your information that I'm doing that. All right, guys. So when you get data, generally you get a CSV file or from a database or from the internet or some form. Usually what happens is you will never get perfect data. Data is messy and data is expensive to acquire. So as you learn more and more machine learning, more and more data science, you'll realize that after you have mastered all the skills, the next big challenge is getting the data. When you go and work for companies, they'll show you their data, but most of their data is behind closed doors. It's not available in public domain and so on and so forth. But the kind of data that you see, whether behind closed doors or in public domain, they will always come with blemishes and imperfections. They'll have some missing rows, something or the other, missing columns, and so forth. So, somewhere you'll have a house, but then it's some things will be missing, proximity to the ocean or something or the other. So, the first thing you do in practical data analysis is you do what is called missing value analysis, which is what I have kept here. Now, what the missing value analysis does is a lovely package here in Python that helps you do it. And there's an equivalent package in R also, those of you who want to do it in R language. You take the missing value package and you apply it to your data. When you apply it to your data, it will show a plot like this. Black is good. Black means data is not missing, but there's horizontal white bars indicated that sometimes data is missing. So if you look at this data, you can clearly see that the total number of bedrooms, sometimes that data is missing, right? So when you look at that, and you can see like how many rows we have for each of the features. Clearly, you can see that this total number of bedrooms where my mouse is, while the rest of them is 2640, This one is only 2433. So obviously a couple of hundred data points are missing, right? So you have to be aware that you may be having missing data. Now, when you look at missing data and there's something also called the heat map. It will tell you what are the areas in which data is missing. Now, this data, California data set, it turns out is extraordinarily clean data, right? So the only things where you have a bit of missing data is the number of bedrooms, total number of bedrooms, right? And there isn't much to analysis. So why is it that I've given these commands? I've given it so that you know. So when you apply it to different data sets, you can apply these commands, these Python functions to them, and you can get a better sense of their usefulness. So what do? When we have so much data, we are rich with data, we can throw away the defective data. It's like, you know, you have lots of good apples. A few apples are bad. You don't need to eat those. You can be in a converse situation. You may have very few apples and all of them may have defects, in which case you have to somehow use the data. That's called imputation. You have to somehow fix the missing values wherever they are. But we won't go there. Now I want to bring you to a tool called a Pandas Profiling. If you use that, you can, on the data, you can say profile report. When you do profile report, it comes up with fairly detailed understanding of the data. It says the number of variables is 11, number of predictors, and then numerical types. How many data types are numerical? There are 10. Categorical is 1. That categorical is proximity to the beach. Number of observations is this one, 20,433, right? Then you can get some warnings right away with the data. It says that the latitude and longitude are highly correlated. It's a very California thing, and you'll see it in the map why it is so, right? And total number of bedrooms is highly correlated with total bedrooms, which makes sense. Bigger houses with lots of rooms will have lots of bedrooms, isn't it? Households is highly correlated with total number of rooms, which again makes sense. If you have a lot of rooms, you're likely to have multi-families, many families living together, right? Population is highly correlated with households. How many households are living? Total number of households living there. Then you look at each of the variables at a time. And now observe, you don't know the look of California, so I will just mention it to you. If you look at the longitude and latitude, just look at the longitude. Do you see that there are two peaks here? Can you guys see the two peaks in this data, guys?
Yes, sir.
Yeah. And can you guess what is happening if in longitudes you're seeing two peaks? It means that in California, there are two major cities at these two longitude locations, right? And that is true. The two big population centers in California are the San Francisco Bay Area, the Silicon Valley, and then the Los Angeles area, the film industry and all that. So that is that, right? The same thing is in bigger pictures here. So there's some extreme values also here. Sometimes people live in remote areas. We won't go. Latitude also shows the same variation. Now, if you look at the household median income, observe something very interesting. Most of these are okay. You don't have to worry about it. But if you look at the median household income, looking at this picture, guys, what would you look at this picture? Or what can you tell about the median household income? Would you agree that most people are earning, there's not a huge disparity of wealth? They are
Yes.
not, it's not, yeah, this peak is very common. So a lot of people are earning in the $30,000 to $40,000 range. right? But very few people are earning too little. You don't see a lot of people earning million or so forth. Hmm. It used to be the characteristic of US, still is to a large extent, that most people are middle class. There are a few very rich people, there are a few very poor people. Broadly speaking, US is middle class, right? And I'll keep going down and look at, so where are we? Median income. Housing. So, oops, sorry. What did I just do? I jumped too far down for some reason. Latitude, how? Oh, sorry. I apologize. Sorry, I completely apologize. I was showing you something completely different and got it wrong. This is the housing median age, not the income. I was showing something completely different. So this is that most houses are, some houses are new, some are old. Most of them are between, 50 years age, 50 years old or less or something like that. So whatever I said before is not true. It's true, but actually the graph for that is different. The graph for that is here. So this is the median income one. Let's look at this in a bit more carefully. If you look at the median income, you see that most people's income, and here the income has been standardized, I believe, to tens of thousands. You notice that most people's income is like more or less the same. There are few little outliers, very few outliers of people who are making much more than you would expect. Right? This is sort of, I don't know if this is typical, but this is very typical of California. May or may not be typical of other states, actually. But for California, most people used to be middle class. Today, things have become a little bit different. There are quite a few people who are extremely wealthy, but middle class people are predominantly still there. Most people are still middle class. Next is you look at the house values in this data. What you see with respect to house values is this histogram. What can you tell guys about the house? Most houses cost between, you know, around 100 to 150,000. And then suddenly you notice this unusual peak. Do you see this, guys? This is unusually high, 500,000, right? Now, this is more or less true of California. If you were to multiply this by a factor of about, in 25 years, I would say multiplied roughly by a factor of 5. Most of the houses in California, outside the population centers, you can get a pretty decent house for $500,000. But in Silicon Valley, in San Francisco Bay Area, and in Los Angeles area, it is hard to get anything below $1 million, right? Or at least $700,000-800,000. Prices have gone really up. And that is what explains this big bump here. It has to do with the fact that the population centers are huge, hugely expensive, the big cities. This is about proximity to the ocean. One of the first things you notice that most people live less than an hour's drive from the ocean. Do you notice that? Right? This is very interesting. Most people are literally living on the bay. Do you notice that there on the island, near the sea, near the ocean, or within an hour of the ocean? Inland is only 6 out of this, 20,000 data set, 20,000 plus number of records. About 6,000, less than a third, live inland, far from the sea. Even far is a matter of definition. Anything more than an hour is considered far here. So, and most people live, like if you look at 9 plus these two put together, about 5, 14,000 people live pretty much near the bay, near the ocean, right? Near the bay, near the water in some sense. So that is that. Now this data, if you look at, there's some correlations between the data. I will let you think about what it means in this correlation. When you get this, try to read these explanations, what is Pearson correlation and so on and so forth. But correlation means if one is high, the other is high, or if one is high, the other is low. That's anti-correlation, negative correlation. So blue, look for strong colors. If you see strong colors, it is either positive or negative correlation. Negatives are red, positives are bluish. So clearly you notice that there's a lot of correlation in the data, but it all makes sense. Like the total number of rooms is correlated with the total number of bedrooms, makes sense. Total number of rooms is correlated to the population. Densely populated areas tend to have within a city block a lot of rooms. Then households living there, again, these are correlated. So most of these correlations will make sense to you, right? Now, this tool is also doing the same missing values analysis. We won't pay attention. Now comes the fun part. Now let's get into the fun part. See, remember, we haven't reached regression yet. We are not predicting the value of the house yet, but we are still exploring the data. So when you're exploring the data, one very handy tool is to use the map. Put the data onto a map, which is what I've done because we have the latitude and longitude. I've used that to do that. And if you look at this, this is the map of, if you're familiar with this California, this will become easy to use. So let me explain, give you an idea of the, the California area. Santa Maria, Redding. Yeah, pretty much. Yes, this is a better picture of California. So do you notice that you have this set of dots here, red dots here, guys? Where it says San Jose? This big area is the San Francisco Bay Area or the Silicon Valley. This is where I live, of course. This is where I'm talking from. The second area is Los Angeles area here, right? Los Angeles and San Diego area. These are the two population centers. Then, one other thing you notice about this state is, do you notice that it is all along the Pacific Ocean? This entire thing is the ocean. So most people live very close to the ocean. This area at the top where I'm moving my mouse, these are the beautiful Sierra Mountains. Right? So all of California is between the sea and the mountains. Right? So it's a very interesting sort of I've now put it in perspective with respect to the entire country where California is. That's that. Now we do this. We take our data, and I won't use the map. I'm just going to use the longitude and the latitude, and I'm going to say, give me this data, but the size of the, now do an interesting game. X and Y are, of course, the latitude, magnitude, longitude. Color it based on the median house value. Means if the house is more expensive, color it darker red. If it is less expensive, color it lighter yellow. Right? So by looking at this graph, what can you tell? You can obviously see that the cities are very expensive to live in. All the deep red areas are either the San Francisco Bay Area or the Los Angeles area, the movie industry and so on and so forth. Now, I've also done one more thing. If you look closely, I put bubbles. The size of the bubbles, I've made it based on the population. So it seems to say something obvious. High density, where the population density is high, you tend to have very expensive houses, which makes sense, right? Big cities are densely populated, and the real estate price, the house prices, is very high in big cities. So, guys, what I want you to learn from this is, leave these things out. These are cosmetics, right? You know, the size of the image. Now you notice that I've changed the size of the image to look squarish, right? This California. It is more appropriate to California. Then this font size, label size, etc. Forget it. But if you think about it, I have created this entire visualization of data using that one line, while the rest of it is just aesthetics, you know, prettifying it. The power of data science libraries is you can achieve a lot with just one function. If you notice here, I have just used one function, scatter. Scatter, this kind of plots are called scatter plots. I've given the X and Y axis, what they mean. Color, how do I give the color? By the way, C map is yellow, orange, red. It is the color map, what sort of colors to give. There are lots of color maps available. It's just a question of which pretty coloring scheme you use. It is more than just pretty. Actually, there's a sensitivity towards not just aesthetics, but to accessibility, color blind people. And as you probably know, 30% of men are to some extent color blind. They can't see all the colors. So these color schemes are made in such a way that it is sensitive to that and it picks colors so that they can see it, right? That is it. I believe color blindness is pretty rare amongst women, but amongst men, it's far more common. So this is it. You can achieve such this entire visualization pretty much with that one function. The rest of it is prettifying it. Now, in this, what I have done is, what was the scatter plot we drew? I put it next to the map. Do you see how the data on the map and just a scatter plot, which is not using a map at all, the two look very similar to each other, the left and the right. Do you see this, guys? These two, do they look very
Yes.
similar, right? Except that the left one is actually on the map. The right one is nothing but a scatter plot, just a scattering of the points. So that's the beauty of data visualization. Now, there is one variable which is categorical, means it takes values which are not numbers, right? So that is proximity to the ocean. We need to handle it separately. I'll just leave it out. Now what I do is I build a histogram for each of the variables. What is a histogram, guys? Can somebody remember from basic statistics? What's a histogram? It's just a frequency plot, Read up on your histogram, what a histogram is. And the lovely thing is that in Python, you can do it with just one line of code, data.hist. Right? Again, I've given a lot of beautifying factors, but the crucial word is just data.hist. If you just gave data.hist, it would have still worked. Okay? It produces the histograms of the data, frequency plots of the data. There is another function which is also very useful. This one, the item number 38, I would say that at this moment, when you're just getting started with data science, it's a little bit hard. Ignore it for the time being. Stick with the histogram. This I'm giving it as a stretch if you want to understand. It builds something called kernel density plots and so forth. This is for people who take more in-depth workshops with me. So you can ignore this part, this complicated picture. You can ignore. Right? These are called box plots. Box plots are plots or a category or the cat plots and so forth. They also are a way to give you a sense of how the data is spread, how the values of a data are spread. I won't say more about it, but it is from your basic high school, high school statistics to make that nothing unusual about it. So I'll skip through all of this. These are just different pretty versions of the same thing. Right. And here, what I'm trying to illustrate is that sometimes some very boring data like this can be represented in a much more beautiful way. And it's also more informative. It's not just pretty, it is more informative in some sense, but we won't go into that. Now, this is again not for you. This moment you can ignore it. Sometimes people want publication quality results from the data. They want to see a table of the data which is ready to be published. Now, when you publish papers or you write research, you write it in a language called text. or a utility called LaTeX. Now, LaTeX, it's written as LATEX, but pronounced as LaTeX. So this LaTeX, if you want to produce that, and I don't imagine anybody in the audience is interested in LaTeX, but if you are, this is LaTeX code. Those of you who have seen written articles or documents written by me know that I write it in LaTeX. Correlation, how related are two elements, right? So this is the correlation plot. We already saw that in the previous, Pandas profiling. So I won't go into it. So that everything that we did so far, I introduce it to you to show that it is important to do exploratory data analysis, and we did it. Now comes the actual regression. If your field, if your column is categorical, if your feature is categorical, numerical, it's fine. But if it is categorical, what you need to do is you need to do something called one hot encoding. Means you need to somehow convert it into numbers. Now I'll leave this as a homework exercise for you. Read what is one hot encoding. Because we can't cover everything in this workshop or today's session. I'll leave that part as homework. If you guys don't understand it, we'll take it up in the next session. Read up what is one hot encoding. Take this as a homework. Why do we need to do one hot encoding of categoricals? Read about it, and then you'll know. But suffice is to say that if you have a categorical feature, you need to sort of somehow convert it into numbers, and one hot encoding is one way to do it. Now, once you have this data, what you do is you can create your X and Y vectors to do regression. And this is it. Now, what was the Y? What was the target variable? It was the median house value, right? And what was then everything else is a predictor. You just remove the median house value from it. It becomes, so you get your X vector and the Y, very much like your homework one. Huh? Now, there is something else I do here in this notebook. I take the log of certain columns. I'll tell you why. If you look at this graph here, you notice that certain columns or certain features, they have a long tail. They're skewed. They have a big skew, household income, households, then total number of rooms, population, total, these things. Whenever your data shows a huge skew, one straightforward way to deal with it is right skew, is to take the log of the data. Now, why is that a good idea? Is a little bit outside the scope of today's discussion. Right? I usually cover it in a more rigorous manner in the subsequent workshops. But at this moment, just take it as a fact that it's a good idea and we should do it. And so we have done it. Right? So that explains why I'm taking the log of some of these columns. And once I do that, now comes the regression. Let's build a regression model. Regression model is, by now, coming from your previous homework, this is very straightforward. What do? I take the data, I take a linear regression, I fit the data to the model, I fit the model to the data, then I make predictions, and then I see how much errors I make. What's the mean squared error? This code is exactly identical to your homework one, nothing unusual. Now, when you look at it, you get a coefficient of determination, the R square, of about 67%, which is pretty good, with a pretty reasonably good accuracy. You're able to predict, or reasonably good, you're able to predict your the price of a house based on the features, right? Based on the number of rooms and location and so forth. The question is, would regularization help? Regularization is something I haven't taught you, so you can just skip this section. Anyway, the answer is not much. It doesn't help much. It doesn't change the answer significantly. Then, how do you use a decision tree regressor? Again, you have used that in your previous homework. A decision tree, just feed it in and you'll get the value for the decision tree. The beautiful thing is you can visualize the decision tree. Likewise, random forest. you can apply random forest to it. When you apply random forest, you notice that, and I'll leave the rest of the analysis to you, you notice that, oh boy, your R square, which is a pretty good way to see how good your model is, it has gone up to 81.48%. Approximately 82%, let's give or take. That's a pretty good model, a model in which you can predict a house price based on its location, the income of the people living there, population density, and so forth. Right? Now, what I
So
didn't
here,
do,
sir,
come again?
in the case, sorry, sir, say in the coefficient of determination, the R square is, I mean, in the previous it was around some 67. So you mean to tell if it is above 50%, then it is good?
No, there is no such thing. I didn't say that. I said it was 67. So it depends on the situation. See, if you are predicting the house price in Bangalore, you are in Bangalore, isn't it? In Bangalore, you realize that it depends on many factors. It depends upon neighborhoods and this and that. But if you can just take the data and predict a house price such that your error is like you're getting an R square of 67, 68%. Usually in that situation, you say it's pretty good. Depends on the situation. See, if you're predicting, it depends upon what you're predicting. Suppose you're doing physics and you're trying to predict the weight, the mass of an atom. You build some sort of a predictive model, let's say, and your R squared is only 67%, it would be considered terrible. Your model, your theory would be considered terrible. On the other hand, if you are in medical field, you're looking at data and you're trying to predict what will be somebody's, uh, uh, like, blood sugar level based on some, without actually pricking the person and looking at the blood, but guesstimating the sugar level based on certain height, weight, and age and other environmental factors, and you get an R square of 67, then you would start dancing and immediately write a paper, a research paper on it, because that would be astonishingly high. If you are in fields like psychology, it would be unimaginably high. If you are in advertising and sales, being able to predict how much you will sell based on certain factors like this and getting a 67, 68% R square, that is ridiculously high. Like it is your dream to get such good values. So what is good or what is not depends a lot on the real world situation. There is no such thing as a good number. All you can do is do the best you can and also do the residual analysis. So if you notice in this notebook, I didn't do the residual analysis, but for your univariate stats, remember I had shown the residuals. It is important to do the residuals. I'll leave that as an exercise for you, as a lab work for you. Do the residual analysis, right? Extend it to do that and see what comes out. By the way, there are no surprises in this. You'll see that all of these models are good. Random forest is, in this particular case, unusually good. You're getting a coefficient of determination in R squared of 81, 82%, which is very good. You're able to predict a house price very well, right? As well as you can in a business world, right? Where there's always, see, when you buy or sell a house, a lot also depends upon the bargaining, whether, you know, whether you can bargain well or not, and many other factors, right? It also depends on the season, the season, the time of the year when you buy or sell. In US, houses are most expensive in between April and October, September. After that, nobody is interested in buying or selling because they have their children in school and or college, and generally school matters. In school year, you don't want to change houses in the middle of children's school year. Right? So that's how you judge. Right? So I will make this thing available on your class website. Your homework is to add the same kind of in-depth analysis to it, to the regression part that you found in lab one. That's your homework. Are we together, guys? By the way, did you like this analysis? This is real data. This is how you apply it in real world. Manasa, since you have been asking questions, are you liking it? Are you finding it something that with some effort you'll be able to do it?
Yes, actually it is interesting, sir, but this is a very new subject to me. But yeah, it is very nice, sir. Thank you.
Yes, see if you can get data from Bangalore and you can predict house prices in Bangalore. If you think about it, in US, there are multi-billion-dollar companies like Zillow and Trulia who do essentially this. They predict house prices, right? And they help people. So in US, what has happened is because of all these platforms like Zillow and Trulia, when a buyer wants to sell the house, they will just go to the website, see, okay, what is the value of the house? And they'll try to sell it for a little bit more than that. They'll advertise it for a little more than that. A seller will do that, and a buyer will come. They will also check out the prices on these platforms, and they will try to quote a number or offer a number a little bit below that, below the value. And that is your margin of negotiation, right? So these things are very real, actually. All right, guys, if that is all I have. If you have any questions, you can ask. Huh?
Uh,
It's quite interesting example, given that specifically in the houses, it's very difficult to judge the prices because there are many factors which are many information which is not available to the buyers. So I think this is a great example to take.
Yes, thank you for saying that. And it is very interesting that business world, real life is very complex. And yet, if you notice, we used only 10 factors. When you take longitude, latitude to be defining a location, then it is basically 9 factors. And with just 9 factors, you can build such good model. It means that underlying themes, there is some pattern, some uniformity, right? There are certain factors more important than others that help you get to very close to the right answer. And then the rest is negotiation. A similar example is the wine data set. We'll use that in classification to determine if a wine is good or bad. So in the West, I don't know if it is true in India, but in the West, there is a lot of ritual. There are people who will take a sip of the wine, they'll roll it on their tongue, and they'll sing all sorts of crazy songs about it, that it has the flavor of some winter or some spring and whatnot, a fall, um, of some region, and they'll get quite poetic about the wine. And so there are people who are paid extraordinary amount of money to taste the wine, and based on the review, the price of wine is set. And these people are very peculiar, very interesting creatures. They practically starve, and they don't eat or drink much. They just wait because they have to keep their tongue very sensitive to taste wine. Now, one of the data sets we will do in this lab is, can you just look at the scientific attributes of the wine and from that tell whether it will be considered good wine or bad? And quite surprisingly, actually, just a few factors are able to tell you whether it's good wine or bad. And so what it did, well, you may say, well, okay, that's what is the big deal about it? The big deal was that it showed that wine tasting is not an art. It's not something very mysterious or deep. Actually, the quality of a wine is based on some very simple factors. So it was quite a sensational result when it first came out, in the sense that it showed that this whole thing is not so mysterious as you thought. And now, of course, that those models are influential in setting the quality or the price of the wine. And there is still wine tasters who tell a lot. And very, very expensive wines are still priced by the wine tasters. But hard data, hard science goes a long way. So we're going to do that in a subsequent week. We are also going to look at breast cancer data, something very real. The cancer. Can you have a machine learning model to predict whether somebody has benign tumor or malignant tumor and things like that? So it is coming down in the next few weeks, guys. Huh? All right, guys. So if you don't have any other questions, I'll close the session.
Sir, 1 second. I have one question, sir. So the homework thing which you told us to do, we need to do for all the 3 datasets, or it is only for one dataset we need to show?
It is only California data set. Today we did only one data set.
Okay. Oh, that we need to take it. Okay, sir.
Yeah. So whatever you learned in your lab one, apply it here. I've deliberately
Okay, sir.
left gaps for you here.
Okay, sir. And sir, the result what we obtain, so we can share it to you or we can share it to Kunal, sir, if he's okay with it.
Yes, of course. I mean, in other words, just keep it here. All I'm saying is that I'm writing a book, and the publishers get very nervous if they find that what you're writing is already publicly available on the internet or it has been shared on the internet. So don't share it with friends, because if you share it with friends, they'll share it on the internet. Right? They will write a notebook, brag about it, and put it somewhere or the other. It has happened in the past. That's why I'm saying it. So just be a little bit careful till I publish it.
So one more question related to the housing prices. I'm just curious to know if these models are,
No, go ahead.
if these models are in place from 1995 or let's say 2000 onwards, which means that people are moving more towards the model-based prices. So is it also driving the outliers? Reducing the outliers?
No, not reducing the outliers, reducing the fluctuation. See, what has happened is the house prices used to be very odd. One guy would sell a house for, let's say, $1 million. Another guy in the neighborhood, in the same street with an identical house, would sell it for, let's say, almost 600, 700,000. The thing is that people didn't know how much a house is worth. They would guess. They would go to real estate agents, and those real estate agents, those dalals, based on how desperate they were to get money from you, if they were sufficiently crooked, they would tell you that your house is not worth much, quickly sell it, and there are no buyers. So the first guy who makes a lowball offer, he'll convince you to buy it or to sell your house, right? Now you don't have that kind of weird behavior because of these models, mathematical machine learning models. Most houses are fairly priced, literally using this sort of analysis that you're seeing, more sophisticated version of the same analysis. That's what these platforms like Zillow, Trulia in the US they do. So in US we all have a very good, very clear idea of what a house is worth. All you do is just visit these websites and they'll tell you using these algorithms. So those things, fluctuations or oddities don't happen anymore. They used to be common before these machine learning models came about. It was very common. It was very much like what probably is still happening in India, right? It's very hard to determine the home value except mathematically, right? Except using data science. So that's that. Outlier houses, people still make their, there are people who make palaces with 100 rooms. So those outliers still exist. They are priced at like 50 million, 100 million, and so forth. Right? Those are, I mean, I don't know. How do you live in a 100 room house? What do you do? Every day sleep in a different room? I don't know. There are people who do that, who have big palaces. In India also, it's very fashionable amongst the rich to have ridiculously big houses, isn't it? So those outliers still exist. I mean, they exist, but fluctuations have gone away from the market.
Yeah, actually, I was referring to the fluctuations in the house prices,
Yes.
not the outlier.
Yeah. So houses, everybody now seems to know what is the fair price of a house, which is a good thing. Because, I mean, these things that you're learning here, they have very practical consequences. Imagine an old lady, right? And in America, some of the older people, when their children fly off and so forth, and they live pretty lonely lives. So these crooks will come and prey on them. and they'll say that, oh, for example, an old lady has to go into a nursing home. Nursing homes will be crooked. They'll say, oh, we will take care of you till you die, but then your house is worth only, let's say, 1 crore or 2 crore. I'll just take a number, 1 crore. But if we charge you, let's say, 1 lakh or 2 lakh a month to take care of you. So based upon uh, how long you live, when you die, whatever amount remains based on this 1 crore value of the house will pass on to your children. And usually what happens is that these people, they used to severely undervalue your house. So suppose your house was worth 10 crores, they would tell that old person that your house is worth only 1 crore, right? And so 1 crore means at the rate of 1 lakh per month, you can live 100 months. You see how it goes, right? So suppose you die in 5 years, which is 60 months, then 40 lakhs is what your children would get. Whereas what they should have gotten is 9.5 crores. Right? So the differences are astronomical. And a lot of old people used to get easily cheated into these scams, right? By all these unscrupulous nursing homes and unscrupulous people trying to sell, grab their property. But today it doesn't happen, right? But today, or the algorithms, everybody will tell you that this is the value of your house, and even an old lady can go to the internet, see the value of the house. If not, their children can see it. So those are the practical consequences of it. Of course,
So
India has another problem. India, like you have a house and you have the title to a house, the paper, and suddenly 5 more parties will show up also with authentic documents claiming to own your house. Is that still happening in Bangalore?
The
Yes,
problem with vacant
it's
sites.
there.
Still happening, huh? Yeah.
Even
It,
now, people are scared to buy some land or something because lot of litigation everywhere.
yeah, it is. I remember that my mother is a surgeon. My father was an engineer. He's passed away. So obviously, when I was growing up, my parents became wealthy. They weren't wealthy when I was growing up. Actually, I left India. I got into IIT, then came. Uh, and in IIT, I had full scholarship. Actually, not only did I not have to pay it, government used to pay me a fairly big sum as scholarship. Those were the days. Then, of course, I came to US on a scholarship and so forth. So I lived a simple life, but my parents eventually ended up becoming rich. But fortunately, they weren't so rich when I was growing up and still in India. But uh, by the time I was leaving IIT and coming to US, there was something very peculiar. People, they started coming up with my proof, literally proof that I was not born in India, that I had come from Bangladesh, I'd come from Pakistan, and so forth. And therefore, there were lots of times they would create police reports. The whole matter would go to court and things like that. And the whole point was to go grab property because I'm the only son of my parents. Grab that property. So all that greed would make them continuously prove that I was a Bangladeshi or a Pakistani or something or the other. It's funny, and they would come up with documents that looked very authentic actually. And imagine that if you don't have the money or the education to go clarify those in court and to prove that you were actually born in India, lived all your life in India, you would lose all your property, quite literally, right? And it's a nuisance actually. It's quite a nuisance to have to face all that all the time.
sir,
So
if
land is a contentious thing. Yeah, go ahead.
just one more question related to the housing prices. Let's say unlike in US, if in India we don't have a database with the price, But if I can get the quoted price from say the websites, for example, there are a couple of websites which shows the price of the house, and they also give some details about the number of rooms, bedrooms, etc. Is it possible to do a similar analysis, and how closer it will be to the reality? Because these quoted
Yeah.
prices always will be an overestimation from the seller, right?
See, there are two aspects to it. And I think some of it, first of all, these platforms in US, they have existed now for over 20 years, more than 20 years. Right? So in US, it's a fact of life. Almost all of Europe, etc., has that. In India, it hasn't existed. I'm surprised that it doesn't exist. But I think a lot has to do with the underground economy. In US, it's very hard to have an underground economy. In India, when you buy and sell a house, on paper you show a very low price. People used to. So suppose a house was worth 1 crore for the municipal city documents and for tax evasion purposes. People would claim that the property is worth only 10 lakhs and they're just selling it for 10 lakhs and buying it for 10 lakhs. And the other 90 lakhs used to go under the cover, right, as black money. So that used to be the practice. I don't know what it is today. But when I
Still,
was
it's
growing
the
up,
same.
it's the same thing, right? So that, it's a very inefficient system because at the end of the day, the nobody really knows what the price of the house is because of course nobody will tell you the real price. It's illegal.
Yes.
I thought this Modi government did something, right, to remove black money. What happened? Did it work or not work? That
It's
whole
still long way. Maybe it will take another 20 years.
20 years. Okay.
Right. Like even people should be honest, right? First of all, people are like to get that kind of expectation from people that might take
Mm,
time. At least what I feel.
mm,
Yes, rules are there, rules are made, but people has to follow. Even now, just go outside. You just walk around, or just take a car and just go 10 kilometers.
mm.
You can notice all the people, police taking money, 10, 20 rupees from people, and simply harassing someone just like that. It is very common in Bangalore at least.
Right. Ah, anyway, nice discussion, guys. See, guys, what happens is as you pick up data science, what is the pleasure in it? Most of the time, see, if you do programming or computer, the traditional software engineering, you're writing some boring code day after day after day, making a UI or writing some backend code or so forth. The beauty of machine learning or data science is every time you build a new model, you're changing the world. You're doing something. And a lot of the things that I know my friends are doing, I wish I could talk about it. It's under non-disclosure agreements. But people are making fundamental changes to the world, often with very simple work that they have done. I remember once in Oracle, we acquired a company because they had an algorithm for reverse auctioning. This was way back in 2006. Today, it looks too trivial. It's so trivial that it would be a very easy data science homework if I gave it to you guys. But at that time, we bought that company for 500 million. The total code base, the entire algorithm, was barely 1,000 lines. Right? So imagine paying $500 million for an intellectual property, the core of which is just 1,000 lines. Right? And that team was a team of just 10, 12 people. So that's how it goes. Ultimately, at this moment, the subject is so hot that first of all, it's much easier to do new things, just gather data that nobody else has so far gathered. and then do a data science notebook on it, like do a deep investigation and build a predictive model. It will have huge economic value, huge business value, and there'll be somebody who will find it very valuable. And basically, this is it. I know so many friends who went from hunting for jobs and struggling to get jobs to overnight suddenly becoming very successful CEOs of their startup, just with you know uh, analyzing, getting hold of some data, building a predictive model, and going to market with it. So it's a very hot field and very productive field at this moment.
So far, what we are doing, like, is it in terms of job role, is it considered as data analyst or the data scientist?
See, in US, right? I can speak for US because I'm a little out of touch with India. Um, Data analysts are very basic things. They just do Excel spreadsheets and so forth. So this is beyond data analysts. Data analysts are not people who build predictive models. That is data scientists.
Okay.
So learn this well, guys. If I'm trying to just motivate you to read the book, do the labs, because the opportunity is huge. I'll give you an example for my team itself. We have been interviewing for a very long time. Prabhat, how many candidates have you interviewed in the last few months? Prabhat? Prabhat is on mute and he may have stepped off. Anyway, we have been interviewing literally, we get a lot of applicants. Out of those, we pick maybe 1 in 20 for interview because the others look. Of those that we do interview, most of the people, the questions that I ask are straight from what I'm teaching you, very basic questions. Most of them flunk it. They're not able to answer basic questions. So look from the perspective of a person like us. We spend so much time to just pick up a person who has basic literacy in data science, who we can use. So you guys become good at it and come approach me with your resumes.
Okay, so, just like on that thought, I got a question in my mind. Like I was telling you, I think in last time, I have like so for 10 years experience in the programming. Like okay, not bad, doing okay. So now from at least from past 3 months, 4 months, I am learning this data science. Maybe another 1 year. I think I get confidence that I can attend interview. So you said like you are going to shortlist the resume. So in my resume, like what I say, write is like I will not have any job experience. Like in relation, we say okay,
Nobody cares.
MBA. Okay,
Nobody cares. Google
okay,
will
got it.
today, Google today gives entry level people who can field their questions and get through their data science, and Facebook and everybody else in US. If you can clear their interview, no one cares how many years of experience you have. They will start you off the bat with a 3 crore annual paycheck.
Okay, because
US.
here it is like something. Okay, how much here is Java experience here or something like that concept here. Okay,
Yeah, see, that is true in programming, Shrikant, but in data science and machine learning, right? It's a young subject. Nobody can claim to have 15 years experience or 10 years experience. Very few people. I have been doing it by luck. My area of work was mathematical physics and computational, all of these things, Fortran and C and machine learning and AI. So I'm one of those rare people who can actually say that I've been doing it for close to 30 years. But it is 1 in 100,000 who can make that claim, or 1 in 1 million, because this field, even all the way till 2008, 2006, 2008, 2010, most people didn't know. In computer science department itself, I did my after IIT, like I did my computer science from University of Illinois Urbana-Champaign, which, by the way, as of this year by CS ranking is ranked as the #1 university in the world. Right. different rankings. Some it's anywhere between one, first, second, third, fourth, fifth, depends upon whose rankings you look at. So I did it from the most rigorous place, prestigious places, one of the most prestigious places. Even there, when I was doing machine learning, I would tell other graduate students, other people doing masters, that I'm doing machine learning. And you know what they used to think? They used to think that I'm doing a collaboration with mechanical engineering because of the word machine in machine learning. Okay? So this field is very new. Even very, very top-notch people didn't know what machine learning is 10 years ago, right? So how can you have experience?
Okay.
You're getting my point, isn't it?
Yeah, I got it. So because
Most
it's
people, and the thing is, experience really doesn't count in this field, because what matters is whether you can come up with a good analysis of the data. I get candidates, whose resumes are sterling. Prabhat, have you come back? Not yet. Yeah.
Yes, I'm here. Sorry.
So do we not get a huge number of very impressive resumes with a lot of experience in
Yeah.
for data science? And
Yes.
how do they prove on interview?
Most of the time, they don't have experience.
They're useless, isn't it?
Yes.
Like
Yes.
experience doesn't matter. They can't answer. And so what proportion of people, of the total number of applicants we get, what proportion manage to clear my interviews?
I think 1 or 2 in 15 or 20, Asif.
Very, very few, right?
Yeah, very,
And
very few.
that is those 20 that you selected out of a
Yeah.
much larger pool, right?
Yeah.
And do I
Yeah.
ask hard questions?
No, very basic.
Very basic questions. So guys, do you realize why I'm saying that this is a great time to enter data science? I ask people very basic questions. And if you really look at the total applicant pool, 1 in 100 can even answer those basic questions. But if you look at their resume, it looks very impressive. I think they must be copying each other's resume, because every resume looks very impressive.
And based on the requirements, people generally put those items, those topics on their resume sometime.
And again, I can give you my experience. I couldn't care less about experience. We make offers purely based on how well you did in the interviews, and most companies do that. All right, guys, it's a late night now. If there are no other questions, I'll let you guys go. Any other questions, guys, before I close? All right, bye, guys.
Thank you, sir.
Thank you, sir.
You're welcome.